Hello everyone. For number 9, we're going to be taking a look at consecutive odd problem, one of those kind of modeling questions. So the key phrase in the beginning here is, as we just mentioned, consecutive odd integers. And I like to, if you get confused with kind of what this means, just create your own pattern here. So let's say 3, 5, 7. Consecutive because they come one after another, they're odd. And what we're noticing here is that we see a constant differential, and if we kept going, 9, 11, consecutive odd numbers are separated by 2. And that's going to kind of lead us into the formation of what we're going to need in a second, that equation to model this. Even if the problem said consecutive even, we'd still be using, if you think about like 2, 4, 6, those are also separated by 2. Where some people make a mistake, they see the word odd, and they think they have to model that with +1 or +3 just because it's an odd number. But like I said, if you just kind of sketch out the numbers here, odd numbers are separated by 2, just like even numbers are. Now in the second sentence, this is where our equation is going to take shape. It says the product. Okay, so product, as we know, is multiplication of their ages, so we're going to label those in a second. The word is, in math, the word is tells us kind of to set them equal to each other, and 783. And it says Jeremy is J, and he's the younger person, younger man in this scenario. So we could say let J represent, just going to shorthand it here, Jeremy's age. So whatever J is in our equation, that will represent Jeremy's age. So if Sam is older than Jeremy, it says Jeremy's younger, so Sam's older than Jeremy and their ages are consecutive odd. That means whatever Jeremy is, J, again Sam has to be older here, will be 2 years older. Okay, because as we mentioned earlier, this drives back over here, odd numbers and they're consecutive, they have to be separated by 2. So this will be Sam's age. Now we have to take this vocab word that we saw earlier, product. So we're going to express their 2 ages as a product. In other words, I'm going to multiply what I just called Jeremy and what I just called Sam together. And we said it is, it's an equal sign, a bad one, but equal sign, 783. So we don't see this as a choice yet, but after some quick distribution, we'll get J times J, which, careful, is J squared, not 2J. And J times 2, that is 2J. And it's still equal to 783. Okay, so now if we look back up top, choice 3 will be our correct answer, as it models what we set up. Some things to keep an eye on here, look at choice 1. Choice 1, even if you had it set up, perhaps you kind of move a little too quickly and you just see the 2 and the J in there, the plus, and you circle choice 1, so that could be a little tricky. Also choice 4, if you for some reason called Sam J minus 2, those would correctly be consecutive odd, but it told us that Jeremy is younger here. So Jeremy, or Sam I should say, has to be plus whatever J is. And as we said, it's +2 because they're consecutive odds. Choice 4 is close, but this last, the last 2 words in this sentence here tell us Jeremy's the younger one, meaning he has to be J. Okay, thank you for watching, and hopefully this helped.